Hello everybody, welcome back to my class. Today we are going to learn about permutation and combinations. In the last meeting we have learned about the factorial notations with Mr. Roy's video, and today we are going to continue. It's about the arrangement. So the arrangements are the placement of something using the given digits. For example, how many different 4-digit numbers can be made using the digits 5, 6, 7, and 8 without using any of them more than once. The first thing you have to do is maybe you can list the first, for example, 5,678 and then 5,768 and so on. And if you are listing all of them, so you will get all of this number start from 5, and we have another number and the couples of them starting by 6, starting by 7, and starting by 8. So there are 24 different 4-digit numbers can be made using digit 5, 6, 7, and 8. But sometimes we will miss one of the numbers, or sometimes it takes using a long time. So this is the first way. I have another way to do this with the same problem using the product rule for counting. Because there are 4-digit numbers, so we put 4 boxes, and in the first place we can put any of the number. We can put 5 or 6 or 7 or 8. So there are 4 ways to fill this place. Because without using any of them more than once, of course in the second place we cannot put the digit we have placed in the first. So we have only 3 ways to fill this place, and for the third, of course we have 2 ways to fill this place, and the last, only 1 way to fill this place. So there are 4 times 3 times 2 times 1 equals to 24 ways. This is the different arrangement. We will use the letter, so can be made using each letter only once. So using the product rule for counting, as we did before, because we have 5 letters, so we have 5 boxes. And the first place, we can use any of them. In the third, 4, 3, 2, and 1. So how many arrangements are there? 120 arrangements. You have learned about factorial notation before, and the product calculations can be quickly and easily evaluated using the factorial key on a calculator. It's denoted as x factorial. It means 5 times 4 times 3 times 2 times 1 if it's 5 factorial, 4 times 3 times 2 times 1 if it's 4 factorial. For integers value of n, remember it should be an integer. It means 1, 2, 3, from 0, 1, 2, 3, 4, 5, 6, 7, and so on. We cannot write as 3.5 factorial or something like that. So what is n factorial? We can write as n factorial is n times n minus 1, n minus 2, n minus 3, and so on. It will reduce until times 1. So interestingly, we can write as n factorial is n times n minus 1 factorial. 9 factorial is 9 times 8 factorial, of course. So n factorial divided by n minus 1 factorial equals to n. Also, n factorial divided by n equals to n minus 1 factorial. So 2 factorial divided by 2 is 1 factorial. It's easy, right? Now, we are going to find the value of 8 factorial divided by 5 factorial. So, using the definition, we have like this: 8 times 7 times 6 times 9. We can write 5 times 4 times 3 times 2 times 1 as 5 factorial. So 5 factorial divided by 5 factorial equals to 1. So we have 8 times 7 times 6. What's the number is? 336. The second one, can you do this by yourself? No, of course. So 11 factorial equals to 11 times 10 times 9 times 8 factorial. So 8 factorial, we can cancel 8 and 8. So we have 3 times 2 times 1 left. So we do the cancellation and simplifying. So we have 165. Another work example. So the gradients. Find the number of different arrangements. Use these 9 cards if there are no restriction. Restrictions means no what can we say that? No terms and conditions. So these 9 cards, there are 9 boxes in here. In the first place, we can put any of them. In the second one, of course, we reduce 1 and 362,888. So 9 factorial is quite big. Find the number of arrangements that begin with grade. So let's say that the grade is 1. It's a 1 place. So grade must be in a 1 place. So grade. So it's obvious. And we can arrange I, E, N, T, S. So in the first place is here. So we can put 5 of them, 4 of them, 3 of them, 2 of them, and 1 of them, because we have I, E, and T, S, 5 letters. So how many arrangements are there? So 120 arrangements. Find the number of arrangements that begin with G and end with S. Of course, G and S should be in the first and in the last. So in the center, we can put R, A, D, I, E, and T. Now, so we have 1, 2, 3, 4, 5, 6, 7. Here, we can put 7, 6, 5, 4, 3, 2, and 1. So we have 5,040. Find the number of different arrangements of these 7 objects if there are no restriction. I think you could do this by yourself. You can do this by yourself, and the answer are on your PDF. And thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh. See you later, guys.